Welcome back, 7th grade scholars. I'm Ms. Whitaker, and I'm excited to have you join me for another math lesson. Let's get started. This is week 4, day 5, and we're going to be discussing SOL 7.10c. First, let's review the You Try questions from yesterday's lesson. Check your answers. Take some time to see what you did differently. If you answer any of the questions incorrectly, then correct your answers. I will go over some of the questions with you. So yesterday we were supposed to graph a line given the equation y equals mx. Number 1 says graph a line that represents the equation y is equal to negative 1x. So the first thing you're going to do is identify the slope. The slope in this equation is negative 1. Okay? If the slope in the equation is not in fraction form, you're going to turn it into a fraction. You do that by placing negative 1 over 1. Okay? From there, you can determine your rise over run directions. Negative 1 represents the change in y. And because it's negative, there you are going to go down on the y-axis towards the negative numbers. Okay? Then positive 1 represents the change in x. So you will go to the right on the x-axis towards the positive numbers. From there, you are going to start at 0, 0. When they ask you to graph a line from the equation y equals mx, you automatically know that the line or that the graph represents a proportional relationship because y equals mx represents a proportional relationship. Okay? So you're going to start at 0, 0 or the origin, and then you're going to use your directions to plot the rest of the points. So from the origin, I will go 1 down, 1 to the right, 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 and so on and so forth. Okay? If I want to plot points above the initial point or above the origin, I will go in the opposite direction. So instead of going 1 down, 1 right, you will go 1 up, 1 left. So 1 up, 1 left, 1 up, 1 left, 1 up, 1 left, so on and so forth. Okay? From there, you can get your ruler, or you should have gotten your ruler or straight edge and created a line by connecting your points. So check number 2 and see if you got it correct. If not, you should correct your answer. But you will use the same process to graph the line. Number 3 says graph a line that represents the equation. The equation is y is equal to 3 over 2x. From there, you identify the slope, which is 3 over 2. It's already in fraction form, so you don't have to change anything there. Now we can determine our directions. 3 represents your change in y, therefore you will move up towards the positive y values. And 2 represents your change in x. It is positive, so you will move right towards your positive x values. Once again, when they give you the equation, they ask you to graph a line from the equation y equals mx. We know that y equals mx represents a proportional relationship. So you can start at the origin or start at the origin, and from there you will move 3 up, 2 right. So 1, 2, 3 up, 2 right. 1, 2, 3 up, 2 right. 1, 2, 3 up, 2 right. Okay? To graph or to plot points underneath the original point, you will go in the opposite direction. So you will go, instead of going 3 up, 2 right, you will go 3 down, 2 left. 1, 2, 3 down, 2 left. 1, 2, 3 down, 2 left. 1, 2, 3 down, 2 left. Okay? And then after that, you should have taken your straight edge or ruler and connected the dots to create your line. Go ahead and check number 4. If you don't have it correct, go ahead and correct it. So let's move on to the lesson for today. What are we doing today? Today we will learn how to determine the y-intercept B in an additive relationship between two quantities given a table of values or a verbal description, including those represented in a practical situation, and write an equation in the form y equals x plus b, where b is not equal to 0 to represent the relationship. Materials needed for today's lesson: you need a pencil, you need paper, and the link to the Desmos calculator. Write down your notes, solve your guided practice problems, and your you-try problems in your notebook. If you have access to a printer, you can print out slides 7 through 9, full sheets, and use those sheets to follow along with the lesson. So today we have new vocabulary words. First word, non-proportional relationship. When the ratio between two quantities do not have a constant rate of change. At this point, we are talking about the y-intercept, and we are getting into different types of relationships that are not proportional. So we will be discussing non-proportional relationships today. Okay? If you look at the graph in the example, it does not go through the origin. Okay? Additive relationship. A relationship where you add the same number to any x value to get the corresponding y value. So before we discuss proportional relationships or multiplicative relationships where you would when you would multiply the x value to get the y value, now we're getting into additive relationships which are not proportional. And here in our example, you can see to get the y value, you must add a value, the same value, to x to get your corresponding y values. Y results from 2 being added to x, or y is equal to x plus 2. Okay? Y is equal to x plus b is the equation of the line where the slope is 1 and b represents the y-intercept. Okay? The y-intercept is where your line intersects your y-axis, or is where the line intercepts the y-axis. Okay? So y-intercept, the point where the line crosses the y-axis. As you can clearly see in our example, it does not go through the origin. It goes through the point 0, 2. That will be your y-intercept, where this line crosses the y-axis. Alrighty, let's move on. Let's discuss additive relationships. The relationship between two quantities is not always proportional. The relationship between two quantities could be additive, which means one quantity is a result of adding a value to another quantity. Okay? So our examples, you can represent an additive relationship in a table. If you look at the table, you have x values and y values. You are adding 8 to every x value to get the corresponding y value. 2 plus 8 is 10, 3 plus 8 is 11, and so on. This is representative of an additive relationship. You also can represent additive relationships in words or a verbal description. So, Thomas is 4 years older than his sister, Amanda. The following table shows the relationship between their ages at given points in time. So when Amanda is 4, Thomas is 4 years older than her, so he's 8. 4 plus 4 is 8. When Amanda's 5, he's still 4 years older than her, he's 9. So plus 4. Each time you are adding 4. It does not matter how old Amanda is, Thomas will always be 4 years older than her. So you must add 4 to her age to get his age. Okay? If B, the y-intercept, is represented by the additive relationship between x and y, then write the equation y equals x plus b for both examples. So example 1, we have a table. We're trying to figure out what's the relationship between x and y. Okay? So each time, what are we doing to go from x to y? What's the relationship between them? Here, to go from 1 to 6, I can add 5. Okay? Let me actually use another pen. Okay, so add 5. 2 to 7. Again, you would add 5. 3 plus what would give me 8? 5 again. And 4 to 9, add 5. Okay? So, the equation we're going to write to represent this relationship would be y is equal to x plus b. So, what we added each time represents your y-intercept, okay, which is b. So, b would be plus 5. Or positive 5. Okay? Example number 2. Kim has 2 shirts for every pair of shoes in her closet. So, Kim has 2 shirts for every pair of shoes. Okay? So, y is equal to x plus how many shirts? 2. And x represents number of shoes or should I say pair of shoes and y represents number of shirts Kim has. Okay? So, let's practice. We're going to find the y-intercept from the table, or we're going to identify the y-intercept from a table of values, and then we're going to write the equation y is equal to x plus b using the y-intercept we identified. Okay? So, what is the relationship between x and y? Each time what's happening, how can I go from 1 to negative 1? 3 to 1, 5 to 3, 7 to 5, and 9 to 7. Well, each time I can clearly see that I am subtracting 2. However, some people might be confused and say, okay, I thought these were additive relationships, but you can add and get a smaller number. You have to add a negative. Okay, so I can add 1 plus negative 2 will give me negative 1. 3 plus negative 2 will give me positive 1. But another way you can represent adding a negative is to subtract. So we can just say subtract 2. So each time we are subtracting 2. Okay, so that is our y-intercept. Okay, and when we write our equation, we can just write it y is equal to x subtract 2. It is easier to write this way instead of y is equal to x plus negative 2. Okay, so when your relationship is actually decreasing and you have to add a negative, just represent it as subtraction. Okay. And number 2, a new ice cream shop only charges $3 for a cup of ice cream. They then charge you $1 for each topping you choose to add to the cup of ice cream. Make a table of values and an equation that represents how much it will cost for each additional topping. So we are going to create a table, and I already labeled the table X and Y. X represents the number of toppings and Y represents the cost. Okay, so if you start out with no toppings, how much will it cost you? It says the ice cream shop only charges $3 for the cup of ice cream. Okay, and then they charge you $1 for each topping. Okay, so if you don't have any toppings, the cup of ice cream will still cost you $3. Okay, if you have one topping, it's going to cost you how much? $3 for the cup plus the $1 for one topping, which is equal to 4. Right? If you have 2 toppings, it's going to cost you $5. $3 for the cup, $2 for 2 toppings. If you have 3, then it's going to cost you $6. So at this point, you can see that this represents an additive relationship. Each time we are adding 3. Okay, so if you have 4 toppings, it will cost you $7. So our equation would be y is equal to x plus b, which is 3. Okay. So at this point, you're going to attempt to do some independent practice problems on your own. You have 4 problems to complete, but the 4th problem has 2 parts, okay? So more like 5 problems. And then lastly, you're going to head over to Clever, log into Dreambox, and complete at least 2 Dreambox lessons, okay? Remember, answers to You Try questions will be displayed in the next lesson. That's all I have for today. I'll see you guys at the next lesson.